try to make this a bit of a thing here. Good grief. Get out of here. Get out. Oh, shit. Good grief. Okay. Channel. Oh, no, wait, I don't need that. That was dumb. Oh, God. Okay. So I'm going to do this for a couple hours. I don't understand why the thing is clipped off on the screen. But that's okay. Oh. Let's refresh the token. Because that's always embarrassing when your Kerberos ticket expires and you're in the middle of something. So, this is all detritus from last night. These are reference implementations of that internet draft that I wrote. Compact UUIDs, awfully useful. And today I'm going to try to figure out what the hell I am doing, which is probably going to be on the order of, what do we got? What do I need to do? So I have this thing called RDF SAC, which is a Swiss Army knife for a bunch of content management stuff. Probably should work on that at some point in the not too distant future. But one of the things that I want to do is productize that, turn it into like a command line tool, and so I don't have to like run it in a REPL in order to make it go. But the dry guy, the one who does dry, which is like a type system for Ruby, or not a type, well, quasi type system, basically input sanitation. There was a bug that I reported back in November that was basically hosed me for producing or creating anything, and they just fixed it like yesterday. And so they haven't released that yet, so I'm not going to work on it until they release that, because there's no point, because I'm not going to ship it against friggin' GitHub master branch. So let's see. Oops. Hey, nope. Stop. D. Reasoner is the last one. So that's all third-party stuff. That's other stuff people made. Oh, I could do the Sugiyama graph. That is actually something I need. Yeah, let's do that. I haven't looked at this in a while. Oop. September. Do I have it? Oh yeah, okay. Port. The hell is that? So I have to commit. Actually, I don't really care. If there was like stuff that was outstanding, I would commit with the date because backdate the commit rather, because then I actually know when I did it instead of like today. Okay, Sugiyama. Let's just load that up in Emacs then. RB graph Sugiyama lib. Oh yeah, I remember I was screwing around with this. I'm gonna have to refactor it. So figure out where that went. Figure out how to do this goddamn Sugiyama algorithm. Sugiyama is the same thing as GraphViz. Sugiyama, it's like a meta framework for drawing graphs like that look like GraphViz. And I want to do something that is similar enough. Well, it uses the algorithm framework, but it is it uses the framework, but it is not. I couldn't just crib GraphViz because first of all, GraphViz is dog ass slow, but secondly, and also like you'd have to pipe it through, like you'd have to generate the dot file and pipe that through and then suck it back out and transform it. Like, forget it. If I want to be able to render a Sugiyama style graph as a in real time, like I cannot use GraphViz, so it's like right out. So basically, I'm going to replicate the Sugiyama thingamajig, and there is a chapter in this thing called the graph. Where the hell is it? Why isn't it's like the graph drawing framework? Let me just. This is Zotero PS. Hierarchical drawing. There we are. This is what I do all day long. I read PDFs and I write code. Not all day long. Well, sort of, maybe. Anyway. Okay, bye Zotero. Don't need you right now. Okay, so I'm gonna just like take a couple minutes to reorient myself here because I haven't looked at this since September. This might actually be the wrong file. This is Ruby PS. I'm like, Ruby's my daily driver because my daily driver used to be Perl, but then I stopped using Perl for like a really like silly reason. Well, not really silly. It's because you can't put anything that's not a string in a hash key in Perl. And like that's like a really anal reason to not want to use already kind of messy ass language. Implementation. So what the hell is this? Class graph implementation. So I think what I did is I started writing the Sugiyama thing, and then I started writing this graph implementation. And then I was like, oh wait, I should just like shove all the Sugiyama stuff into the graph implementation because that actually makes sense. Where the hell am I? this stuff is on GitHub. I don't know if you like care, but like it's on, I think it's on GitHub. Should be on GitHub. Let's go look at where it is on GitHub, just cause. Hey, stop that. Oh, God damn it. Let's try that. Yeah, so there it is. If you feel like following along. There. Plop. Okay. That's enough out of you. This might actually be like the most boring possible. I mean, I guess I'm really selling it here. So the Sugiyama process, let's go back to that PDF, is, and this is like, you can download this if you just Google for hierarchical drawing algorithms. It's in there somewhere. And it looks awfully familiar if you've ever seen what GraphViz looks like, you know. So what I want to do, where'd you go? Oh, it's like right at the very, very end. So these like radial ones, that's what I want to do. GraphViz won't let you do that. And yeah, anyway. So I need the guts of the Sugiyama algorithm, or the, you know, it's not strictly, it's funny because it's like in 4 parts. So you got step 1, which is you've got to layer the things. So where'd you go? Yeah. So first step is you put it in layers. Second step is you minimize the edge crossings. When am I gonna hack the Gibson? God damn it. Yeah. Hackers penetrate and ravage delicate systems of private and public, how does that go? Stealing information, and these people are terrorists. Hackers penetrate. This might take me a second to like figure out what the hell, because I really haven't looked at this in not years, 6 months. No, 5 months. 4 months? Whatever. Instrument graph. Okay, so this is just your basic graph implementation. Directed graph gives you information about what's in it. It's like supposed to be just, you know, the idea is like presumably you've got your graph in some other implementation, and this is just an implementation that exists for the purpose of like schlepping around into an actual visualization. So oh yeah, so rank for sources, sinks. So this is just all metrics. This is all just like crap that it needs in order to like compute, for instance, a layering algorithm. Remove source, target, remove image, and edge. So components, tight slack Oh yeah, okay, so feasible tree, that was probably what I was working on last. You know, it's kind of funny when you're translating an academic paper. Well, this is actually a book chapter, but translating an academic paper into an actual, actually running code is like surprisingly a pain in the ass. Well, maybe unsurprisingly a pain in the ass because, I mean, God, just, you know, they give you like some pseudocode maybe, and they give you some like math. Where'd the math go? Oh, there's just math in there, but they got like, you know. Yeah, math. So, layer assignment. Rank, feasible tree, normalize. Okay, so let's just find feasible tree. That's probably a better, good place to start. Well, st, leave edge is not nil. Enter edge st exchange. So, good old graph programming. Anybody ever do this? I suppose I should like mention on Twitter that I'm doing this like I said I would. Come on. What in the hell? All right. Oops, idiot. I am like almost certainly not going to implement this in the next hour and a half, but because there's a lot of code to write and there's a lot of shit to read. But I'll do some of it. Okay, you can go. This looks like, yeah, this like totally looks like what I was doing for 5 months ago. Fuck, I can't even count either. How am I gonna hack the Gibson if I can't even count? Initial rank. Where is initial rank? Oh yeah, so I like wrote that. That's a thing. Scan rank, nodes by degree, give us a Q. This may loop forever if the graph has cycles. It's funny, like anything you ever have to do with graphs is like always gonna be sketchy. There's always stuff like the computational complexity of like, you know, trying to compute like a partition is n factorial or whatever, or 2 to the n, whatever. It's enormous, and like you can't really do exhaustive algorithms on stuff, and you gotta like find dodges and hacks, and then there's this like I don't know, it's like weird. Anyway. Okay, what does this do? Initial rank. So that's the first thing. Let's find the feasible tree algorithm, wherever the hell you are. Maybe it's back here. Or maybe they don't even tell you. They just tell you in the pros, like what the frick. Welcome to the lulzy world of... Let's like look at that again. networks. Okay. The network simplex starts with an initial spanning tree built by this procedure feasible tree. Gansner suggest. Longest path layering and take the span on tree is short, so direct the layering into this. Each iteration in the while loop removes an edge of the spanning tree, which breaks the tree into two connected components. Then a new edge is added to the tree that connects the two components into a new spanning tree. Two edges to leave and enter the tree respectively are chosen such that the new tree induces a layering with a lower dummy vertex count. Do I have dummy vertices in this? Okay. Might as well return the hash, the rank. Might as well return the hash of the rank. For those who are just joining us, I am implementing the goddamn Sugiyama graph viz algorithm so I can do something fancy with graphs. It's going to be real neat eventually. Okay, so what is this even doing? Nodes by degree. Okay, so this gives us the nodes sorted by out degree minus in degree. Why? Oh, that's nice. Okay. BL out degree. CIP. So that's like probably something that's in this sucker somewhere. You want to get the like chonkiest, thickest nodes first, and then you descend. So that's what that's doing. And then, so you get the rank. So what is the rank? What's it returning? So node, okay, node to rank relation. Let's like fire up a REPL and see what the hell this thing even does in a second. Maybe now. Okay. God damn, that takes so long. The streaming like pins your friggin' CPU. 4 node, compact max, blah blah blah. Okay. Test if the inbound edges have been scanned. So you queue up the nodes, order them. This is already sorted by the chonkiness of the node. And then it's a queue, so it will have like, it will stick stuff back into the queue if there's nothing, which is why it says it. I wrote to myself that it would loop forever if there are cycles, but there aren't supposed to be cycles. Or may loop forever if there's cycles. Oh, there's cycles and no, that can't be right because there's a scan node, set new. Yeah, whatever. If there's cycles, I'll fix them later. type. How the hell do I even populate this thing? Initialize copy. How do I def initialize? Hey, there you are. Oh, I see. So you can have nodes and you can have, so you don't, yeah, all right. Fun. We can just like do this. And like anything can be a graph, add edges st. Oh, that's fun. So I can go like foo, lol, what, banqua. Well, maybe I can't. That's weird. That should work. Unless I can't read. Add edge. Well, that's undefined method. Edge st. Add edge st. Let's look at the add edge. Def edge. This is probably wrong. Source. Target. Yeah, I think this is probably wrong. It's a good thing I caught that. Okay, so we have, I mean, part of the reason why I'm like friggin' inventing the wheel on a goddamn directed graph implementation anyway is because I need stuff like weights and I need stuff like I just need like stats so the thing isn't like computing over and over again, because I want to be able to like, you know, compute stats. Anyway, okay, so let's just like in degree and out degree, like if you have to calculate those every time, like you only need to calculate that when the actual graph changes. But other graph implementations don't do that. Source key target. What is going on here? What is this? Target. Well, there's always just the, you can always just add a warning. Source target. So those, okay. So add, what happens when you look at def add nav in degree at degree nad, yeah. And this thing doesn't care like what you put in the graph. I mean, I suppose it, I don't even know if it should. Okay. That's totally not right though. That doesn't make any sense. Oh. Source target. That doesn't make any... Why did I even write that? That's ridiculous. Yeah, no shit, I'm mumbling to myself. Jesus. I mean, the whole point of this is to, like, you know, actually demonstrate, you know, make it, like, slightly more transparent what the fuck I'm doing all day, and this is precisely what it is. What the, like, you know, does what it says on the tin. I didn't promise anything else. Mumbling to myself, no shit. So this is like forward source target equals rev target source equals weight. This is just like putting the damn, but this doesn't make, why the fuck did I even do that? That shouldn't even be there. The hell, man. Coad. I wonder if that's gonna bust shit. Wait, 1 minute. Forward. Yeah. So you got the grass. That punts out. All the stats are correct. Those should be the same objects too. Like the actual same thingamajigs. Dot. How do you do this again? Is that right? Okay, so those are totally not the same objects. That's not... Maybe that's what that was supposed to do. So is this like... Forward source target, rev target source, that's correct. But that doesn't make any sense. Why I would ever have done that. Just a second here, let's try something. Oh. Right. Yeah, so those weights those are the same object, so those weights will change. That's what I want to be sure. It's actually the same hunk of memory. Okay, so what happens if I type? What do I? Try that again. Was I like huffing paint when I wrote this initially? Jesus. Well, that looks like it's cycling. That's not a good sign. Good job, me. It is probably cycling because it is not. You know, I'm like beginning to think I just wrote this and never ran it. What kind of insane fever dream was I doing? Fucking. Oh my god. Okay. Okay. Food, what does that do? That should be empty. Okay, I'm not going crazy. And okay. So let's try something. Pushing node. Pushing rope. See what happens. Yeah. Yep. Okay. I don't know. Rank 4 node. What happens if I do it now? So that one's got a rank. Scanned now. Neighbors out. Wonder why. I mean, obviously, if there's something left in the queue, it's going to keep looping. Min empty. Neighbors in is empty. Or Yeah, I clearly never ran this code. Christ. Because I would have noticed. Well, I don't know. Good question. Anyway, okay. So we shift the node off the queue. We test if the inbound edges have been scanned. Nin equals neighbors in node. Nin to empty or nin to reject. Scan. Scanned. Okay. What am I saying here? Because the other possibility is, if that's like in there, rank dot values, node, or node, highest in degree rank plus 1 defaults to 0. Rank for node rank dot values at nin.compact.max, nin, neighbors in. Minus 1 plus 1. That's very strange. Like it should, like I just made a graph that's just like a, it's just like a two-legged thingamabob. And for some reason it is loading, or it is looping indefinitely, which it definitely should not. Reject. Scan. This is probably wrong. This guy right here. Scan. So scanned is a neighbors out node dot to set. Let's just try something here. Scan dot fetch. So we're going to scan the n, or just neighbors in. So we go from the neighbors, if nin dot empty, nin dot reject, scan fetch include node. So node is the one we're using. Nin is neighbors in. And that should, let's just like do it the old-fashioned way. Oops, that's not what I wanted. That's what I wanted. Okay. Yeah, okay. Bizarre. So this is saying, this should be saying that like for everything in the in degree, if everything that's coming in, or everything in the inbound neighbors. Check the neighbor, but it's not clearly not adding. Because that's empty. So why is that empty? Because it shouldn't be empty. It should have the contents of that in it. Okay, neighbors out node to set. Maybe that's not doing some stuff. Let's do something here. Oh yeah, how about write the file? Always good to do. Whoops. You know what, I got an idea. Since those are busted anyway, let's do that. Okay. So what's going on there? Oh, Jesus. E key, I have to replace this keyboard this week. That's fucking whack, dude. What the hell? Well, no wonder, goddammit. That's okay. So that, you know, this is one of the things that annoys the shit out of me about Ruby is the occasional, like, you know, we have this mutable object, but, you know, assignment doesn't actually do anything. So what's happening here is that, so I'm setting S because I don't feel like, but this is what I'm going to do. Oh, God. This will probably work. Syntax error my ass. Unexpected operator assignment. Oh, no, you didn't. That's not good either. Because the operator precedence is going to bone that. So that's not good. Whatever. line that up. Ooh. Okay. That's what I need. That's what I want. This should work now. Yeah. Okay. I could reverse the hash. Ah. That's fine. It's fine. Everything's fine. It's fine, okay? It's fine. All right. Where were we? Got the initial rank. Components. Ooh la la. Until tight. Yeah, I think it's all coming back to me now. I'm like Celine Dion up in this shit. So that gives us the rank. So if I like puts the rank into the nodes, which is always fun. Funny thing about these pseudocode algorithms is like, you know, they kind of make assumptions about some stuff and assumptions about other stuff. Like assumptions that you'll need a particular variable, and then like also assumptions that like you're gonna have state stuck somewhere that it doesn't even talk about. Okay. We can get rid of the warnings too. It's awfully tacky to leave warns in code, even if you comment them out. I mean, especially if you comment them out. Or maybe not. I mean, like, if you're, it's kind of like saying, oh, whoops, like, I had trouble at this point in the future. I wasn't too sure about what the hell was happening under the hood, so I had to print a warning. Initial cut values, what is that? I mean, besides the obvious, graph fully connected. This graph is not fully connected. Why? Yeah. I love my like trailing off in the middle of a damn sentence too. Fucking. We want this to return true if what? What? I think we consult the this guy again. Okay. So, feasible tree. Compute the longest path. Let's go back to Zotero and figure out if I downloaded that other Gansner paper. Looks like I did. This is the GraphViz paper. Hey, go. Okay, let's see if it starts talking about the feasible tree and all that good shit in here. Oh yeah, and PS, like, I could just look at the GraphViz source, but it's like fucking completely opaque. It's just like I don't understand what the hell is going on in it. I couldn't even tell you where the code that actually does the job is in the graphics source, and I'm like, not for lack of trying. Negative cut value indicates blah blah blah. If I have to like actually read this shit, I'm gonna stop the stream because I'm not gonna just like sit here gawking at a PDF file while I'm streaming. Procedure, feasible tree. Okay. Okay. For brevity, initial rank is not given here. Blah, 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 blah. For brevity. For brevity, we're not going to actually... It would be like really nice if you just like had the code, you know, in a nice annotated way, you know, in your... The actual code that you could execute in your fancy academic paper, and like, you know, also not just like in a PDF that you'd have to scrape it out of, but actual like, you know, even if it wasn't... You know, even if it was like in Pascal or something, I would be able to still at least make sense out of it, as opposed to like have to figure out like from like math equations what the hell they're talking about. So this is the guy. This is the guy we are just copying. Well, tight tree. The function tight tree finds a maximal tree of tight edges. I don't remember what they mean by tight edges. I think it's like edges that are only one sort of grid unit long. So like these are tight, that's not tight. Yeah. Yeah, so the feasible tree, I don't know what these are. Cut, okay, we gotta figure all this shit out. Init cut values function computes the cut values, blah, blah, blah. Rank plus delta. Incident node is E head. Delta equals slack. What's the slack function? Blah, blah, blah. Of course it doesn't actually tell you. It probably does tell you somewhere. So you have like an inventory of bits and pieces. Okay. You have an inventory of bits and pieces, but like there's no index of functions or anything. Like you got like all these things and concepts. Okay. Given any ranking, not necessarily feasible, the slack of an edge is a different of its length and its minimum length. Thus, a ranking is feasible if the slack of every edge is non-negative. An edge is tight if its slack is 0. Go back to that little graphic. So that one's like -1. Just tight. Tight, tight, tight. It's tight. Of its length and its minimum length. Well, that doesn't make any sense there. Those are length and its minimum length. Marking the nodes as belonging to the head or tail component for each true edge. Shit. Uh-huh. Like Zizek here, freaking rubbing my nose. It's itchy though. God damn it. Okay. Tight tree. Let's go look at what tight tree is. Do not tell you. Function tight finds a maximal tree of tight edges containing something. Okay, so if it's gonna say like finding a maximal tree, that probably means like not the spanning tree of the entire thing, but like subtree. Okay. I know what this is saying. It's saying that a tight tree is a subtree of the graph such that all of the edges between the nodes are quote unquote tight. And what this is doing is ranking it based on the, so this function returns, so I have it here as a predicate because it ostensibly made more sense that way. I don't know if that's true. So we just want this to return true. Okay. If this is where my like fall off the friggin' face of the earth in the middle of the sentence, we want this, just want this to return true if it can find a spanning tree which is tight, or once it is determined. Once it has determined, or if the procedure it can, hey, come on. Now, I don't know about this part. Because this is like, if you have like a disconnected graph, you know, those elements are gonna, this is never gonna be true. Because there aren't gonna be, so you should probably like all nodes that have an out degree of 0 or just a degree of 0, you're gonna want to like have that separate, because otherwise this is gonna loop forever. If your graph is not connected, this is gonna fucking go forever, because this is always gonna be false or true, I guess, in this situation. It'll always be false here. That's what this is about. And I feel like Sherlock fucking Holmes here, decoding my own goddamn insane fever dream. Okay. Okay. How about we just finish this thought? Because this will always be false. It won't necessarily fail. The graph is, because the definition by definition, can only be true. Well, this is basically a tautology. This is basically saying the same thing twice. Slack source target, initial rank. This is definitely like helping me keep my attention. I'm not like fiddle-dicking on Twitter. Not that there's really anything interesting. I guess there's no like insurgency or anything going on at the moment. There's no doom scrolling. Okay. So what do I do about, like, this is gonna obviously not work if like your input has more than one component in it. If it's got more than one component, it's gonna fucking loop forever. That's no good. So what that tells me is that this whole thing is gonna have to like account for that at some point in some other thingamajig. Because otherwise, yeah, I mean, obviously the academic stuff, whatever, but you know, obviously the real implementation of GraphViz is going to have to handle that. And I mean, when you look at it, it just puts the disconnected stuff on the top rank, which, you know, duh, of course it's going to do that. But I mean, the algorithm as is in the papers is not going to do that. It's going to have to be accounted for. But we can deal with that when we need to. In fact, I'm just gonna like write this down right here. I think it's GSV93, GSV93, and well, it's just whatever. GSV93 paper does not take into account more than one disconnected component. More than one component. But obviously, this whole schmozzle is going to have to account for that. Okay, back to life, back to reality. So this is where we twiddle. This is where we twiddle the ranking. Where was that paper? Okay. Oh, and that's probably why I wrote all those like, so like incident neighbor. See, yeah, okay. Tight tree, incident and non. See, this is what I meant about the goddamn academic. So this predicate, where'd that go? This predicate's actually no good. And the reason why that predicate is no good is because Because you actually need the return value of this fucking thing. That's what this is. And this is why academic pseudocode is a pain in the ass. Okay. Tight tree. A tight tree. See, even this thing, like this function, method, whatever, it's going to be confused if there's more than one connected component. Because, like, how is that going to, what's that going to return if it's, okay, you're like ranking the thing and so what you want is you want the tree. So this, first of all, I'm going to need like way more sample, but well, I mean, I could just use sample from the actual paper, so that's fine. But yeah. So if this is, yeah, if there's more than one connected component, basically there's more than one like island in the graph. Like, how is this gonna? It's the answer is gonna be indeterminate. You know what? I might have actually thought this out already, because I think I saw something in here that was a components method. Yeah, okay. What happens when I like load that in the thing? Oh, doy. I should make that look like that, look prettier. But it's not important. Actually, this is useful for now, but. Well, that's fun. Components. Yeah, so there. That's what I'm talking about. You got two components. So I think that then, if this is the case, then these, well, this tight thing, let's just like fucking, first of all. I'm not going to delete that yet because I find deleting stuff memory holes it, and then I'm going to forget like even more, like what the hell. I think this was a good exercise though, because I I mean, I remembered that I had like started off down the rabbit hole of like writing this other implementation thing, this graph colon implementation. And I was originally going to use like, obviously originally going to use a third party graph implementation, but you know, graph implementations are actually really easy to write. And that thing like just didn't have like, it should memoize, it should cache stuff like stats that are only computed when you modify the graph anyway. So these things all have ranks now. And if I add an edge, what this is going to go. Ooh, that'll be interesting. Oh. That'll be doubly interesting. Implement initial rank. So that'll calculate components. Components. So now there's one. Self. So now you got two tops pointing down these ranks here. Neat. Fun. So this will be like okay. Okay. I have a feeling that once I have implemented this, and it's a really kind of interesting exercise to implement stuff out of an academic paper, or more than one academic paper in this case. Because like you got a really in your bones knowledge of like what the actual problem is. But I find also too often, especially when you're like implementing it in a different language, I mean, these guys were doing it in C. When you implement it with a different language, you get to use different language features. Like I'm using, you know, hashes and sets and stuff like crazy in here. You know, what the necessary stuff is and what the like, you know, was a completely implementation dependent thingamajig, you know, for something, you know, in this case, 28 years ago. Which is also kind of interesting too, like just how long-lived an actual algorithm is compared to like any implementation of that algorithm. So onward, I'm going to do this until about noon. It's 11:23 now. And then I'm going to go to the pool. And then I'll probably do something else later. Okay. That's clever. Okay. Interesting. This should, yeah, okay, it is private. Good. Phew. Okay, well that's not as bad. Okay. This might not need to be private, but whatever. We can move it later. I'm not like super fussed about that. So tight tree, let's give it an initial node to start from, because then that's basically what it needs. And let's give this an initial I feel like I'm gonna have to modify all of these things for connected components, making sure that you. Oh, look, I did it again. Oh, I just did it again. Didn't finish my goddamn sentence. That's not a sentence, but whatever. Components. Node keys.toSet until pool empty. Yeah. Yeah. Okay. I'm going to go to the top of this private here. Okay, ground rules, dumbass. Maybe I'll call myself a dumbass. I3 paper does not account that. Does not account for the possibility that there are more than one connected component in the graph. So the algorithms that they specify either don't have algorithms that specify either don't have a provision for operating over more than one component, or will loop infinitely, or both. So we have to modify them a bit. E.g., put in an initial node. Which may or may not be at the top of the tree. What I could do is I could combine this initial rank thing with the components thing. That would be clever. I say as a bit of a joke because your code is not supposed to be clever. It's supposed to be anti-clever. This, though, can come out. I'm going to cut this out right now. I'm going to put it... It's interesting, you know, it's funny because it's like clearly I thought about this because of where that is. But it can go in the public API. It doesn't have to go in the private parts. Let's call it origin. The node to start from. Nodes by degree. Again with the origin. Gonna need to find that nodes by degree. Where did I put that? No. Origin. Me type English good. Okay. Okay. So what we'll do is we'll make a spanning tree. We'll make a private spanning tree. And then a public one will just like strip off the like, because like, okay. Start with an origin, and then what you got to do is find the neighbors, and you recursively find those neighbors, and you recursively find those neighbors, and on and on and on and on. And that's how you do that. And so let's just do that. I'll just call it. What happens when I do that? Value must be enumerable. Ew. Oh, who's fancy now? No method. Oh, you can go like that. Okay. So if I said, oops. So this is going to return a set. This is going to, so we have set.new, set, plus Okay, so we start with that. And then we want to recurse. No. We go, I know what to do. Nope. Actually, we don't want to not care. Okay, so arriving today. No shit, eh? I'll believe it when I see it. Watch these assholes come when I am. So I ordered a package on January 1st, and the fucking e-commerce site didn't put my buzzer number on the way bill, and so they sent the package back to the thing, and it sat there for 18 days. Okay. Okay. And origin scene. This is what we do. Okay. Return scene if scene origin. No. Yes. Yeah, sure. I mean, it's not the cleanest. That's probably it. Let's try it. Okay, that looks like it works. If I say derp, shouldn't be in there. Yeah. Okay. I feel like there's a better way to do that. Whenever I write a recursive function, I mean, okay, there are a lot of bad things that people can say about Paul Graham, but one good thing he wrote was a book on Lisp about like 25 years ago, and it was actually good, and he should have stuck to that, but he said a couple of really smart things in it. One was if you're going to write recursive code, you write the exit condition first. And the other thing was And this one like kind of blew my mind in a stupid way. So an array is a hash where the keys are integers, and I was just like, anyway, he says dumb shit on Twitter all day long, just like me. Actually, not just like me. His shit he says is like excruciatingly dumb. Anyway, okay, spanning tree internal. Is that even? Whatever. So, where did that go? Components. No. Initial rank. Q nodes by degree. Nodes by degree. Nodes by degree. Ugh. Okay. Here I am, like, killing it in the middle of a sentence. Okay, object. Where to start? Option. Where to start from? Okay, and nodes equals origin. Hey. I guess you can't have nil as a graph object. Yeah. I mean, that's probably a bug, but I don't give a shit right now. No. Nodes. Oh, look, it's too long to fit on the line. Where are we gonna cut it? Let's do that. We'll just take that off. Okay. That's not right. That's also not right. Of course. Of course. Of course. Values at has to go like this. Duh. What did I? What do I think I'm doing here? Oh, god damn it. Okay, class hash. Doesn't matter which one. how you say like a subset of a hash where the keys are. That's kind of where I'm after. See values at, that's not what I want. Merge, check, replace. We reject. No, it's going to be select. Yeah. Okay. It's not values out. It's like it's. So here's what we're going to do. That's kind of why I wanted the whole, whatever. Whatever. That'll do it. Yeah. That'll do it. Okay, so doesn't include K. So what that's doing is that's getting the spanning tree from the origin, or whatever the hell origin I put in. So if I put one in like dir, it'll give me the same one as foo. And that's in the order of degree, which is the one that we want. Okay. Although, no, we won't do that. Although maybe we do want that. Maybe if we wanted that in a hash rather than a set, because then we don't have to fuck around. Yeah, let's do that, actually. That was... Let's do this. That's why I wanted the internal spanning tree. Let's do that too. And by that I mean, like, if there's return an empty thingamajig if there's nothing in it. And now that is actually more sane, because this is a hash now that looks the same as the nodes object thing member variable, instance variable. So it's got the same structure. It just doesn't. It's just its own spanning tree, and then you don't have to. Then I don't have to do that dumb ternary there. I can go back to a ternary. I don't have to do, because I already have it. I already have that data. I don't have to compute it a second time. That's usually good. Where'd you go? What did I call that again? Rank. Nodes by degree. It'd be nice if I remembered where I put it. Okay. So we'll just go back to that. Orange nut mill. Nodes. Let me just do this. Bam. And get rid of that. Herder. Oh, God. Okay. Highly amuse myself here. Okay. So. And so now like an external spanning tree would just they would just give you the keys. Just strip off the, because all you need is the nodes from the spanning tree, and then you can get them back. Okay. Nodes by degree. Good. So this is like pretty boring, right? But it beats sea shanties. Or does it? I don't know. Rank 4. Sync sources. This is all the fun shit. Alias method. I'm gonna call it quits in 8 minutes anyway. Or maybe a little bit longer. Components. Okay. Let's go back to that paper. Okay. So the tight tree, that's what we want. Or all these things are going to need their origin. So call it, what am I calling it? Origin. Not initial. I mean, I could call it initial, but I'll call it origin. Let's give it some doc string. Defined in GSV 93 as a subtree of a subtree, JK lol, it isn't defined, you have to read between the lines. Extra lol. It's a subtree and a connected component such that all edges between the nodes are tight. It's self-defined as the edge only spans one rank. Didn't mention in their paper. Near law. I guess I could make an array of the nodes in the tree. I'm assuming Nat you fucked off, which I don't blame you. You're probably like off of the Dominican Republic or some shit, vacationing like a Frenchman, as one does, or at least as. Okay. Tight tree. Are we ready to write some code? What is that going to look like? What is that going to look like? Oh, God damn it, get out of there. I really, really, really wish you could pin the friggin' Mac OS dock to one monitor, and it didn't do that all the time. I have to like coax it back. I don't know whose goddamn idea was that. It was stupid. Okay. Tight tree. I'm gonna actually. Tight tree. Okay. Well, we'll start with the origin. And I guess we'll do something similar to the spanning tree, but we'll like. Okay. This is also private, so we can just see equals. Yeah, we'll just do that. Whatever. So we will do this. Origin, okay. But this time we will return the keys of the scene. No, this can be a set. And we'll just return the set. I mean, I prefer to, I mean, if the set is just a hash under the hood in Ruby, I think anyway. So we'll go return scene dot. No, this is, yeah, we'll turn scene if nodes include origin. I don't remember what the damn operator precedence is. I mean, I've had like ambiguities in the past. Okay, so scene origin, we'll add that. And neighbors origin each do tight tree origin. Neighbors dot origin. Select. Let's just names are origin select. Okay. Nodes n. We also want like O equals nodes origin. Get the actual metadata of it. Minus O rank. So we'll also do that so that it doesn't null out. Is that right? What if I say, yeah, Okay, so you just do that. You don't have to math that out. That's a JavaScript thing. I bet you the operator precedence for this is, let's actually just look it up. I'm gonna guess that the like double bar, yeah, it looks like shit. God damn you, DuckDuckGo, and your garbage ass search results. Like, hooray, privacy, boo, garbage. Okay. Precedence. What does that mean? It's high? Yeah, that's high. Okay, so the double bar versus a minus sign. No, the minus sign is higher precedence than the double bar. Okay. Select. These are all going to be smaller. So what I'm going to do probably is wipe this graph and, okay, first of all, let's put this on a new line. I'll wipe this graph and start again. Neighbors.origin select. So what this is going to do is give me all of the ones that, did I even, it's going to give me all of the ones where the rank is 1. That's the definition of the tight tree. Tight tree. All right, I'm just like, make sure that I'm, yeah, okay, so I called it rank. So, and these like, they just got the bit. I'll just do this actually. No. N equals, no. Okay. Here's origin select N. That's a number. Yeah. Dot each. Do and again. It's a different thing. It's a different scope. Sloppy. I don't care. Can put that on one line. And it's recursive. And then we end it with scene. Hey. A little room. Okay. Scene. Ha! Fun. I'm having a feeling though that that's actually not right. Because everything on this graph is like within 1 of each other. So that should actually, I think, with the exception of, maybe not. Now I'm confused. You know what though? I'm gonna shut this down now anyway, and like get ready to go to the pool. And like, of course, the goddamn shipper is gonna come while I'm swimming. It's really like too bad you couldn't just be like, hey, can you just like hold off until like 2:15? Anyway. Where'd that go? Thanks for watching. Can't believe it, but okay, bye.